Hey guys, it is a great day to be in room 625. It is. Today we are going to talk some more about slope. I know we talked about this keynote a very little bit before we went to e-learning, but I kind of want to take my time and explain it a little bit better. So let's look at it. So the slope is, or the rate, slope is the rate of change, and it's a ratio that compares the amount of change in a dependent variable of the y to the amount of change in an independent variable x. And slope measures the steepness of a line on a graph. The rise is divided by the run. So right here you see the slope is the rise over the run, which is this change in y, which is the change in x. And we represent slope with the variable m. That would have been B period. It's time to go. So I'm creative eating lunch right now. But this is what we represent slope by, is the m. And today we're going to start off by finding the slope given a line, and then we'll find the slope given 2 points of a line. So we talked about this, slope dude, that if slope dude's going on an adventure and he's sloping up a hill, he'll be saying puff, puff, positive, because he's working out pretty hard. He gets to the peak of that hill, he goes down, and that's when he says nice, negative. Then when he's skiing on the flat part, he says this is zero fun. That's a slope of 0, a horizontal line. And when slope dude falls off the edge of the cliff, that's when he utters the most horrible curse word in all of math, and that is undefined, as he falls off the edge of the cliff. So those are the 4 types of slopes you may have. And when you look at your answers and you get these answers, it's good to kind of think back to slope dude and make sure that if you have a positive slope as your answer, that it's going uphill, or if you have a negative slope, that it's going downhill. So find the slope of a line given a graph. We talked about this yesterday. This is when we find the bottom point, and we count up and we count over. So slope is always the rise, which is up, over the run, and that's horizontal. I'll always rise up, then run out. So here is my bottom point. To get to the same level as my upper point, I'm going to rise up 1, 2. So my slope is going to be, so far, a positive 2. And if I run to the right, that's positive. If I run to the left, that's negative. I'm going to go left 1, 2. So that's negative 2. So that gives me a slope of negative 1. Go over here. Pick my bottom point. I'm going to rise up 1. So my fraction is going to start with a 1 in the numerator. I'm going to run over 1, 2. So my slope is 1/2. Down here, I'm going to rise up 1. So m's going to equal 1 over something. Run over 1, 2. So 1/2 is my slope on that line as well. It just says it intercepts the y-axis at a different point. Besides that, it has the same slope. A little preview, these 2 lines would actually be parallel because they have the same slope. Go down to this one right here. I'm going to rise up 1, 2, 3, 4, 5. So my slope is going to be a 5. And then I'm going to run over 1, 2, 3, 4. And since I'm running to the left, that means my denominator is going to be negative. And when I write slope, I can just write that as m equals 5/4, and just keep that negative sign kind of equal with that fraction bar. So it looks like that. Y equals a negative 5/4, because that does tell us to go left, but if we follow the rules of slope, we're always going to rise up no matter what. And if it's negative, that tells us we're going to run to the left. So that has a slope of negative 5/4. If you look, negative slope, nice, negative. 2 positive slopes, puff, puff, positive, and another negative slope, nice, negative. So the thing about slope dude, when you do these, make sure that you have them right. So not always will you be given those dots, given those points on the line to find slope. You will have to find your own points to do that. And when I talk about your own points, that's where if I have, if this is like the grid of the graph, where a line crosses through, where all 3 of those lines intersect, that's what a good point is. So I'm looking for some good points on here, 2 per graph, in order to find the slope of that graph. So right here, I see a good point right here, and I see a good point way up here. So let's see what the slope of that graph is. I'm going to rise up 1, 2, 3, 4, 5, 6. And I'm going to the left 1, 2, 3, 4, negative 4, which is the same as m equals negative 6/4. And with fractions, with slope, we always want to reduce. We don't want to change the mixed numbers. We like improper fractions. Slope, we want to have improper fractions. So we're going to reduce this to m equals a negative 3/2. Negative slope, nice, negative. Down here, I have a point that's good, and I have a point that's good way up here. So we'll go up 1, 2, 3, 4, 5, 6, 7, 8. So my slope of 8 over 1, 2, 3. Slope of 8/3. Down here, I have a good point right there. And I have a good point, looks like right here. So we'll go up 1, 2, 3, 4, 5, 6, 7, 8. So my rise is 8. My run is 1, 2, 3, 4, 5, 6. 8, 6. It's positive, so that's good. So I can reduce that to say my slope is 4/3. And if we check that, let's see if we go up 4 and over 3 if that point's on the line. Up 1, 2, 3, 4, 1, 2, 3. Yep. 1, 2, 3, 4, 1, 2, 3. If you can kind of imagine 1, 2, 3, 4, 1, 2, 3, how that would still be on that line. Same with this up here. If I go up 3 and then over 2, 1, 2, 3, 1, 2, 1, 2, 3, 1, 2, 1, 2, 3, 1, 2. That slope is constant for the entire line. Okay, last one down here. This is a good point right there. And that's a good point right there. Up 1, 2, 3, 4, 5. So my numerator is 5 because that's my rise. And my run is 1, 2, 3. 3 is going to be a negative 5/3 because I am running to the left. So that's how you find slope given a graph. Let's talk about 4 more because a couple of these have some of our oddballs, some of our oddities. And that's the first one. Right here, we have a horizontal line. And we have a horizontal line, think of slope. If he's skiing on a flat surface, he's saying this is 0 fun, this is 0 fun. So this has a slope of 0. You can also think of it, pick 2 good points. Pick a point there, pick a point there. How much would you rise up? 0. How much would you run over? 1, 2, 3, 4. Gives you the same slope, 0. I have a good point right here and a good point right there. So I am going to rise up 1. I'm going to run over 1, 2. So I have a slope of 1/2. And let's see if that slope's constant. Up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2. So that would work for the entire line. So it doesn't matter what points you pick because it's going to give you the same answer no matter what. Right here, it's straight up down. That would give us a slope that is undefined. And the reason it's undefined is let's actually pick 2 good points. If I pick a good point right there and a good point right there, I'm going to rise up 1, 2, 3, 4, 5, and I'm going to run over 0. And I can't divide a number by 0. That's a little thing we do with Siri when we ask her what's 0 divided by 0, what's 5 divided by 0, and she comes back and says, Cookie Monster's sad because he has no cookies, and you're sad because you have no friends, because you can't do it. It is undefined. It's impossible to take something and to divide it into 0 groups. You can take 0 and divide it into 4 groups really easily. Everybody gets 0. But if you have 5 markers, and you need to divide that into 0 groups, you can't. No matter what you do, there's going to be at least a group or 5 groups of something. There's always going to be groups of something. Right here, I have a good point there and a good point right there. So we'll rise up 1, 2, 3, 4, 5, 6, 7, 8. Slope of 8. Or rise of 8. 1, 2, 3, 4, 5. It's 5. And it's a negative 8/5 because I ran to my left. So puff, puff, positive. Nice, negative. This is 0 fun. Undefined. So that is how you find slope given a graph.